Hello my data buddies, I hope you have watched this previous video where I talked about the Snowflake specifically and its roadmap, the Snowflake developer profile, how the demand is in the industry. There are thousands of job openings for the Snowflake developer profile itself, plus the service and consulting companies are hiring for this role very aggressively with mind-blowing package like more than 20 plus LPA. And in that video I dedicatedly shared a complete roadmap of learning the Snowflake, like if you are a beginner, how you should proceed and what all important and core things from the Snowflake you should definitely cover. But let's say you have learned the Snowflake, still there is a lot of gap on the internet where you will have a hard time to find a really good project which you can work on and you can add it in your resume. And that is what we are going to cover in this video, like a complete project built on top of the Snowflake and using the Azure cloud as well along with it. So doesn't matter what kind of profile you are targeting, the data engineer, data analyst, data science, or dedicatedly Snowflake developer. So Snowflake as a skill set is gonna be really must to mention, and the practical experience of building the project on Snowflake will increase your chances to crack the interviews. So watch this video and build this project which is all about the Croma. I hope you have heard about it and you might have done the shopping from it. So the complete data warehouse modeling on the Snowflake, and then the KPIs, business analytics, right, and building the entire event-driven pipeline, all those things we will be implementing in this project. So very good and extensive project. So a proper production grade kind of problem statement, the data model and the data set we have used. So make sure to watch it till the very end and build this project end to end. And after going through with this project video, make sure to give a like in the big number so that we can spread this project to all the aspiring data professionals. And if you are new to the channel, then make sure to hit the subscribe button and press the notification icon, because really soon we are bringing a lot of cool project driven videos on this channel. A really important announcement for those who want to learn Snowflake seriously, basic to advanced, with the industry grade project, and especially if they want to learn it from a certified Snowflake developer itself who is working in the industry and has a really great experience of building the scalable data warehousing solutions on the Snowflake. So on our platform Grow Data Skills, we are launching the very first live classroom program of the Snowflake Mastery. And in this bootcamp, you are going to learn the entire Snowflake in 6 to 8 weeks with the proper industry grade project, which I said obviously the certified Snowflake developer is going to teach. You will be having the live classes, live doubt session, offline doubt sessions in the Discord, placement assistance, proper help in the job hunting process, resume building, LinkedIn profile building, quizzes for every section, assignments, their solution, interview preparation guide, help in the certification preparation, and all of those things. If you are looking for something like that, then this is the bootcamp you are actually trying to find, but you are struggling because there are a lot of platforms who are charging 50k, 100k just to even teach 20% of the Snowflake, which we are doing at so minimalistic cost and keeping it very affordable for all the aspiring data professionals. So this is the bootcamp for very limited number of people. The link has been given in the description, or you can visit www.growdataskills.com. Plus there is a very special discount offer. For that I have given a special coupon code in the description itself. Check that out and avail that one. Plus if you have any query or you want to discuss things directly with me, then this is the mobile number where you can give me a call or you can drop a WhatsApp message and I will be able to help you directly.
So a quick overview first. I will be covering few slides related to the introduction of Snowflake, what actually we mean by Snowflake, what is its architecture. And after that, I will be covering a mini project which will be based on Croma. So it will cover how various data sets are pulled in for Croma, how it is loaded into data warehouse, and after loading, how it is processed, and the relevant insights are gathered through that data set. So what do we basically mean by Snowflake? So before Snowflake came into picture, we just had traditional data warehouse or traditional RDBMS systems in place. So for if I take a quick example, let's say of Teradata, I used to download Teradata, install it on my machine, There were various hiccups in it. If there are multiple users using it, the queries used to work slow. The scalability and flexibility were not there. There were no transparency with respect to costs and a lot of things. So the moment Snowflake came into picture, this basically served as a cloud data warehouse system. So this is, you can say, a software as a service package, or you can also say it's a data warehouse as a service, but on the cloud. Okay. So the reason why Snowflake is being used or why it is so popular in the current data engineering world is because there is no effort involved at all for its installation and setup. There is no maintenance involved. Everything is done in the backend by Snowflake team. They push the updates on regular basis, be it if there are major updates, they are pushed on monthly basis, then some updates are pushed on weekly basis. And also they do take the consent of the account owner as well. So whichever client or company have account with Snowflake, they basically take their consent as well. Okay. Now, the advantages of Snowflake is you have storage and compute separate. What does it mean is I have a separate layer called storage layer in which my data is stored. There is no dependency of that data that, okay, this data can only be accessed only by a particular team, or if it is being accessed concurrently by multiple users at a time, then there will be a problem or there will be latency. There is nothing such complexity in case of Snowflake. So it basically offers us an advantage where we can store, process, and analyze massive data sets. At the same time, it also gives us a feature of scalability and flexibility. Now, the best part about this is since we are in an era of data security and data governance, so Snowflake also offers automatic encryption for the data. Along with that, the data which is stored in Snowflake, the basic unit of storage is called a micro partition, which is nothing but a compressed columnar format in which data is stored automatically by Snowflake inside the database storage layer. Now, with respect to the compute part, so similarly, the way we spin up clusters when we use Databricks or when we use EC2 instances, similarly, in case of Snowflake, there is a concept of virtual warehouses. So virtual warehouses is nothing but the clusters which are required for the computation when you will be doing any operation like a select operation from the database, or you will be loading any data through Snowpipe. So those all features require warehouses to be there. This is used for the providing the compute resources in Snowflake. Now, the biggest advantage is because Snowflake is a cloud hosted software as a service, it is compatible with the top three supported cloud platforms which are there in the market. And we definitely, one or the other cloud platform we are working with these days, whether be it AWS, GCP, Azure, each and every company is gradually either moving to these or they are already working on it. Now, what are the differences which we notice when we say that, okay, these are the differences or the features of Snowflake, or these are the pros and cons of traditional data warehouses? So if I talk about architecture and flexibility, then the best part is this is cloud native, it's multi-cluster. The amount of compute or the more concurrency, more better performance you need, you can accordingly modify things. You can do a vertical scaling, you can do horizontal scaling. It totally depends upon your requirement. While on the other hand, in case of traditional RDBMS systems like Teradata, Oracle, the on-prem part of it was the tough part. Accordingly, we had no flexibility, or it was not that much scalable, the comparative to what Snowflake offers. Along with that, the setup and maintenance part. So you would still be remembering that whenever you work with these systems, there is a separate outage window which was taken over the weekends, and the database administrator team used to email that, okay, at this point in time over the weekend, there will be maintenance going on. So database will not be accessible or the performance will be down. But that is not the case in case of Snowflake. It is a fully managed software as a service, which is entirely managed in the backend by Snowflake. While in case of traditional systems, there was complex setup. You had to install a lot of drivers. You have to give the path for the settings file, those all things. Similarly, when I talk about scalability, so as I said, depending upon the requirement, it can be a horizontal scaling, it can be vertical scaling. So if my system has, let's say, thousands of users accessing the system at the same time, I will be doing horizontal scaling, which basically means, let's say I have a virtual warehouse which has just one cluster at this moment. So I will spin up few more clusters so that more nodes are available for users to use. Now let's talk about storage and compute. So in case of storage, again, Snowflake stores the data already in a compressed format. The charges which are applied to the user, they are in terabyte levels. So there are very few dollars which you have to spend for each terabyte of data which is being stored. And the best part about is you have to pay separate cost for storage and compute. So for compute, you have a per second billing with minimum billing duration of 1 minute. And for storage, you have separate compute at terabyte level. While in case of traditional systems, that was coupled, which was a big disadvantage, you can say. Now the key features of Snowflake. So the key features of Snowflake are: one is time travel. As the name suggests, time travel basically means that I can go back in time up to a certain extent, which in case of Snowflake is 90 days, and I can restore any accidental updates or modifications or if I lost any data. Okay. So let's say I have a table, I have a database. So inside this database, my table will be having a particular time travel duration. Using that time travel duration up to those many number of days, I can go back. I can check, okay, what was the table DDL or maybe what was the table data which was available that time. And those accidental issues can be resolved. But the only one condition for that is it has to have time travel enabled. If time travel is enabled, only in that scenario, the history will be able to recover. The next point is zero copy cloning. As the name suggests, zero copy cloning basically means I have a table, let's say. Okay. Now I am cloning it. Cloning means I'm taking a static snapshot of that particular table with that point in time data. But whatever changes I make to my new table or my new data, those changes will not impact my original data set. That is the primary advantage of this data, what I am having as part of my original table. Along with that, the best part is I will not incur any additional cost. Whatever cost I have incurred before for my original table data storage, that will be the only cost which I will incur for my original plus new table. There will be no additional cost unless I am doing a DML operation on my new table, because it does not create new micro partitions. The old for old micro partition, it creates a reference, and using that reference, the cloned object is used. Now the third part is secure data sharing. So in secure data sharing, what happens is, let's say I have a customer who might or might not have a Snowflake account. So what we will do is, in real time, if I have to share that data with my user, and I also have to make sure that data has to be within my premises. It's not going outside my cloud, or users should have just select access only to the data. There is a feature called data sharing in Snowflake. Using that feature, we create an outbound share. User imports that data as a database, and there are specific roles created through which user will be able to access it. If my customer or user does not have a dedicated Snowflake account, we can create a read-only consumer account within our Snowflake account as well for them. It will be having a different URL, but it will be within the same organization account. So the org admin or account admin will be having access for the same. Now, pay as you go pricing model, which basically means, let's say I have a virtual warehouse. My data is only coming 4 or 6 times in a day. I cannot keep my virtual warehouse up and running because that will cost me additional compute cost, right? So that idle time cost, in order to avoid that, there is a specific feature called auto resume and auto suspend. So let's say I have set auto suspend to 3 minutes. So after every 3 minutes, warehouse will shut down. And if my auto resume is true, then whenever you can say a new data set will come, warehouse will automatically resume, and it will help in execution or processing of the data set. This will make sure that I have an uptime as well. Along with that, I can also make sure that I have cost is also saved. Now let's go to the Snowflake architecture. So I guess just a second. Let me just quickly see if there are any. Okay. So, okay, just a second. Attendees can chat with everyone. Okay, that's fine. I think, yeah. So Snowflake architecture. Now Snowflake has a 3-layer architecture. Okay. The first layer is called the cloud services layer, which is this blue box highlighted. Okay. This is also called the brain of Snowflake. The second layer is the virtual warehouse layer, or you can say the compute layer. And the third and the last layer is the storage layer. Okay. Now, the cloud services layer, this performs various functions, starting with authentication and access control. Now, what do we mean by authentication and access control? So anyone would like to mention to me in the chat what will be authentication and access control? Can anyone quickly would like to mention? What do we mean by authentication and access control? It's login, it's verifying user. In order to access, we need to have credentials. Correct. So similar to this, there are a couple of things. There are two concepts. First is authentication. Second is authorization. So this authorization is access control. Now authentication means Snowflake will validate that, okay, I am a valid user who was provided access to Snowflake by the Snowflake sysadmin, security admin, user admin. There can be any of the roles who provided me an access to this particular Snowflake account, and I am authenticated to access it. Now, the second part is access control or authorization. So what does this mean is, let's say I have developer access. So as part of developer access, I should have just access to specific schemas, let's say staging schema. I should be able to create objects in it. At the same time, I should be having minimal access for the business layers or the presentation layers. So authentication and access control, be it a human user who is accessing Snowflake, be it a service user, or be it a system. It can be through a lot of various ways are available. SIM is one process, which is SCIM, that can be integrated with Microsoft Azure. Then Azure AD authentication, Active Directory is also one process. Okay. Next is infrastructure manager. So what does this do is, whenever there is a requirement that, okay, it does see that now virtual warehouses also have a facility where adaptive warehouses concept is there. So if we switch on that option, then Snowflake has a feature that it will take a call that, okay, I have these many queries already running, but it seems that my current size of the warehouse is not sufficient to process these. That's when it will take a call on its own and it will change that warehouse to is from a small to medium, medium to large, depending upon the requirement. Now, optimizer. Optimizer, what it does is whenever there is any query submitted to Snowflake for execution, optimizer basically parses that query, prepares the query execution plan, and then it redirects that query to the warehouse which is least loaded, so that that warehouse can quickly process that query. Similarly, transaction manager, metadata manager, you can say this layer also takes care of all the metadata management. Metadata, as we know, it is nothing but data about data. So whatever data is there in Snowflake, there are certain secure views, right? We have a Snowflake dot account usage dot the view names like users, roles, grants to roles, warehouse usage history, metering history. There are more than 50 plus such views which are available as part of information schema and account usage schema. So those all metadata operations, along with that, it will also store, let's say, what all files were loaded by Snowpipe last time, so that it should not load that same file again. Then comes security. Okay. So overall, everything which is related to authentication, authorization, security, metadata management, infrastructure management, query optimization, those all things are taken care by the brain of Snowflake. Now, you might or might not be knowing this, but Snowflake architecture, a lot of people say that, okay, it is partially shared nothing, partially shared type, shared. So they say basically it's shared disk and shared nothing, both 50-50. But the foundation of Snowflake architecture is based on the key value pair concept of Foundation DB. Foundation DB is an open source database which was designed by Apple. So what it basically does is, the best part is it works on the concept of stateless service. So what happens is there is no client involvement required and multiple requests can be handled parallelly in the backend. So what it does is, even if Snowflake is deploying a change to your account in the backend, there is no outage for your account. You can do your operations like a everyday thing. There is no difference. Okay. You will not even feel it that Snowflake is doing something in the backend. Now, next is virtual warehouse. Okay. Virtual warehouse, as the name suggests, is a compute layer. Whatever query is submitted, so optimizer prepares the query plan, but that execution is taken care by the warehouse. Each warehouse corresponding to its size, whether it's small, the t-shirt sizes, it has extra small, small, medium, large. It also has a corresponding cache allotted to it as per the size of that warehouse. So that's why whenever you would be, if you have run already some queries in Snowflake, you would be seeing that query is spilled, query is spillover. So that parameter which you see in your query profile, that parameter denotes nothing but because your warehouse size is particular value, it exceeded its cache, and then that's why it got spilled over to the remote disk. So till the point a warehouse is shut down, whether it's due to automatic or it's manual, till the point that your warehouse will retain its cache. If you have run a query on a warehouse previously, and if it is not shut down, maybe in another 2 hours, 3 hours, 5 minutes, you will get that query result faster unless you change anything in that query. It should be exact as it is. Similarly, the brain layer or the cloud services layer also has a cache which is called results cache or the query cache. But the time period for this is fixed to 24 hours. Let's say I have run a query select star from employee. First time it might take few minutes or let's say few seconds for me. But the moment I will run it next time within the 24 hours, it will take less time. Also, every time I run it in the next 24 hours, it will keep on increasing or shifting that 24-hour window. Let's say today at 1 p.m. I ran that query. So my 24-hour window is next day tomorrow 1 p.m. But if I run it again at 1:30, then my 24-hour window has shifted. Until 1:30 p.m. next day, I will be able to fetch the same results. Now let's talk about the storage layer or the databases part. Storage layer is nothing but whenever we load any data into a Snowflake, it automatically stores it in compressed columnar format. It is one of the most optimized formats. It stores it in form of micro partitions. And the best part about that is the micro partitions are immutable. Okay. So whenever your data changes, a new micropartition will be created, but old micropartition will not be altered. This helps in maintaining the data integrity. Along with that, since it is storing in the columnar format, whenever I am running a select query with a few where clauses, it will prune my data. It means is I will be able to get my result in a faster time. Along with that, Snowflake will not need to scan the entire table. It will just filter those values straight away since it's on column basis. It need not scan entire rows. It will just fetch me my required columns. That is the best part about this. Okay. Now quickly, let me have a look at the chat in case anyone has any questions. Nope. Okay. Let's move on to the next one. So as I said, the layers of Snowflake architecture which are there, I told you about the cloud services layer. So this is nothing but let's say a scenario whenever new virtual warehouses needs to be provisioned, then cloud services takes care of it. If there is a query which is attempting to access the data being updated, it makes sure that it's waiting for the update, but you will not see it it will all happen in the back end. You will not see that lag anywhere in the front end. Whenever you will get the data, it will show you that latest data set. It will not happen that in the backend some data is there and you are seeing some other data. Now, same about the query processing layer, which I already mentioned, that virtual warehouses are independent of each other. I can have a separate virtual warehouse for loading the data from an ETL tool, let's say Azure Data Factory to Snowflake, and I can have a separate warehouse for querying the data from Snowflake through Power BI for my business users. The moment warehouse size increases, the number of nodes also double. So the moment I'm increasing the clusters, let's say it had initially one cluster, two cluster. So since the nodes are increasing, my cost is also increasing, but at the same time, my compute is also increasing. So I will get better performance or better concurrency depending upon my requirement. And at the same time, the cost will also proportionally increase. Now, as I said, the database storage layer. So it's stored in a centralized location and it's automatically partitioned and compressed, which is the optimized columnar format. Now, Snowflake also takes care of clustering, or you can say automatic data management. So whenever you have a table which has, let's say, terabytes of data, or which has more than 300, 400 gigs of data, that table Snowflake will automatically take care to have automatic clustering done on that. The only scenario is, or the only condition is, if you define a clustering key which has a medium cardinality, Snowflake will have a better option to optimize its performance in a better way, and it will cluster it in a way that it is optimized also for performance. And since the data set is huge, so it is also stored in a way that you are not incurring more cost. This is a basic glimpse of how a Snowflake screen looks like. You might or might not be aware that now Snowside is the default view. Going forward in couple of months, they will be removing the classic console entirely, and Snowside will be the default view for all the users. Now, as I mentioned to you, that our agenda in long term is having a full-fledged Snowflake bootcamp. So I will quickly give you a walkthrough of that bootcamp. The duration of that bootcamp will be of 6 weeks, which will happen over the weekends. It will be 12 days of classes. The duration of each class will range between 2 to 3 hours. Our week one will start with Snowflake Fundamentals, in which day one we will be preparing the basics, or the, you can say, we will be laying down the foundation. So if you are someone who is just starting with Snowflake, you are already a data engineer who is about to start on a Snowflake, you are already working on a Snowflake, you want to learn some advanced concepts, you want to brush up your concepts, you want to learn other things, so those all things will be there. So be it fundamentals, Snowflake architecture, what are different differences between the Snowflake editions, those all things, provisioning of account, web interface overview. So I'll be going through all the panels in details, what each panel holds, how you can provision, let's say, a network policy, network rule. What do we mean by virtual warehouses, resource monitors, those all things. Day two in first week will be having your data storage, how basically data is stored, how you can notice that difference through the querying, because we cannot see that data directly, right? We have a SQL in between. We can see that through SQL only. So how we can see whether caching is being used in my query or not, whether it is fetching the data set from the virtual warehouse cache, query results cache directly from the database, what all constraints and operators are there, because you must be aware only not null constraint is enforced, not everything or not each type of constraint is enforced in Snowflake. What all kind of databases we can create, permanent database, transient database, types of tables we have, dynamic, transient, iceberg, everything, permanent, temporary, types of views, be it semantic, materialized, normal view, secure view, role-based access control, which is the key concept in Snowflake. Then week two will be around data loading and ingestion, in which we will be covering about the loading lot of things. Then after that, third week will be revolving around the data transformation and security. So data masking, row access policies, what all metadata tables are there, how to write stored procedures, data sharing, caching. Then week four will be more towards advanced features like building streamlit applications, semantic views, clustering, FinOps in Snowflake, time travel, data sampling, network rules. Week five will be more or less around performance and best practices, connectivity with various tools, be it Python, Power BI. We will also be using DBT inside Snowflake, which is a recently introduced feature in the summit. We'll be also going through a lot of interview questions. Then at the end, in the last week, we'll be having two capstone projects, which will be similar to the real-time industry needs. The first project will be based on Zomato data warehouse, where we will be seeing that, okay, how this food delivery platform is basically taking the data as input, what all kind of data massaging is required, what all analytics are involved in the backend. We will see Streamlit dashboard, Power BI views on top of it. We will also see how slowly changing dimension is being implemented, what all KPIs are there. In project 2, that will revolve around Maruti Suzuki. So in Maruti Suzuki, we'll be building a data engineering pipeline that will be again having continuous data ingestion, lot of streams, tasks, those all things, everything we will see. Okay. So Now let's on move to the uh, okay. So now let's on move to the real-time project which we had planned for today. Okay. So that is nothing but the Croma retail chain. So you must be aware of Croma. It sells a lot of electronic items and also phones, your gadgets, everything, right? So definitely it's generating large volume of data. Here we have considered a sample data set. So the introduction is that we have a Azure blob container in which file is uploaded. There is a Snowpipe setup done. There is a queue and event created. The moment file is loaded, the queue gets a message, event gets triggered, that message in the queue is consumed by the Snowpipe and it loads that file. We have three separate layers. First is the raw layer or the landing layer. This layer is where we have the raw file data, which is being directly loaded as it is into Snowflake. INT layer or integration layer, you can say, is the transformation layer where we have dimensions and facts. Presentation layer is the business layer where business users will be accessing the data. Okay. So I will quickly show you. This is the Snowflake account. I have done some setup already. So to keep in interest of time, you can see this is the Croma database which is created. If you see in databases, it will show you I'm currently in worksheets, right? So if I click on this worksheet, you can see as of now, I have created this using account admin. These are the contexts you have to mention. First is your role and second is the virtual warehouse which you are using. So you can see I have used a virtual warehouse 𝗏_BI, which is a small size. So in order to create a warehouse, you will use this command. You can also create it from the UI, but also you can create it manually. If you do not mention the size, by default, Snowflake creates a virtual warehouse with extra small size with 100 credits. Okay. So let's say if I want to check what all are my warehouses. So I will run show warehouses command. This will show me what all warehouses are existing. What is the state? Type means we will cover in detail in the bootcamp. There are two kind of warehouses: standard, which is gen 1, and then there is a snowpark optimized, and then there is gen 2 warehouses. So these are standard gen 1 warehouses. These are the sizes, minimum and max clusters, how many clusters are running. Then remember I mentioned auto suspend, auto resume. Auto resume should be true because we do not want any downtime for our business. Then you can see when it was created, which was the role which it created. By default, also for each trial account, Snowflake creates one warehouse by default, right? Enable query acceleration. It is one of the performance tuning process or feature that we will see in the bootcamp. Query acceleration factor, resource monitor. You can see, as I mentioned, it's a Gen 1 warehouse. Okay. Now let's go further. So these warehouses have been created. Okay. There is a database called Croma. Okay. And there are three schemas. First is STG, second is INT, third is PRS. So if I expand Croma, information schema and public, these you get by default with each database which is created by Snowflake or even by us. Irrespective of the database which is there, you will always find information schema and public. Information schema will be the metadata kind of schema and public will be the default public schema which exists. Okay. Now we will go to Azure. Okay. I will go to the storage account. So in my storage account, I will go to storage browser. I will go to blob containers. I will see I have a container created here. Okay. And this container will be having various folders. You can see this has 6 different folders, which mean there is a possibility that data will be received in some of these or all of these on daily basis. Okay, since it's a transactional system. Okay, so 3 schemas have been created. Okay, there is a file format also which is created. Why? Because the files which I will be loading, those files in this case, we have considered CSV, which is comma separated values. So these CSV files also will be loaded. Okay. So that's why for creating a file format, again, you can create it from worksheet or you can create it directly. It's advisable if you create it from worksheet, you will get to know what all are the features in it. So type is CSV, field delimiter is, as I said, comma separated, skip header one because my file has a row of headers which are nothing but my column names. Field optionally enclosed by, it is possible my file might have fields which are enclosed by double quotes. If it's null, it will replace it with the value. Okay. Now the next concept is I have uploaded the file, let's say, but how my Snowflake will get to know or how it will authenticate. So for that authentication, there is a Snowflake object called storage integration. This Snowflake object basically makes sure that it is establishing a secure connection between Azure and Snowflake. It basically serves as a bridge for identity and access management between Azure and Snowflake. Okay. So I have created this storage integration. The type is external stage. Why? Because my files are outside Snowflake. So this is not inside. Had it been inside, it would be internal stage. Since it's outside, so it's external stage. Storage provider is Azure. If you are creating it on AWS, you will mention AWS. Enabled as true. Azure tenant ID, this is nothing but your Microsoft account level. So this is at account level. Whenever you go to your account and you click here, Microsoft Entra ID, you will find an option here which will show you the tenant ID value. Okay. Meanwhile, it loads. Let me give the other value. Storage allowed location. This means whatever blob storage account I am creating, that blob storage will be having a particular path, which all paths I want to allow. If I also want to block any value, I can also mention storage block locations. Since I do not want to block anything at this point in time, that's why I have not mentioned that. Okay. So you can see this tenant ID. This is nothing but this value provided here. This tenant ID does not changes until your account has changed in Microsoft. This is at account level or an account level parameter. Okay. So this storage integration is created. The moment you create this storage integration, okay. I'm sorry, by mistake I placed a single quotes semicolon there. Okay. The moment you create this, you will describe it. Now I will tell you why you need to describe it. When you describe it, there are two fields which are of most important to you. One is Azure consent URL. This Azure consent URL, you need to copy the value and you need to paste it in browser. This admin consent you have to provide, which makes sure that, okay, it is allowed to access. It will not show you consent here because since it takes some time to reflect sometimes in Azure, that's why I had given this consent already today morning. But you will have to do this. The next part which is of importance is this ID which is generated. You can see multi-tenant app name. Okay. So you need to copy this first part value here. You need to go to your storage account, and so that Snowflake is able to access the file, there is a value which is, or you can say there is an access role which is called storage blob data contributor that is granted. So I'm inside my storage account. Now I will go to access control IAM. I will check my access. Okay. So I can check my access here since I have already granted it. If I would not have granted it, then it would be showing separately. So what I will do is, otherwise, let's see it from the beginning. So if I go to add role assignment, you have to search it by blob data contributor here. Storage blob data contributor. Okay, you have to select this. You have to click on next. You have to search for the member. So the value which we had copied from Snowflake, that value we will pass on here, right? We will select this and we will review plus assign. Okay, since it is already assigned, so it will not do anything further, but had it not been assigned, it will add it. So let's see, it's adding role assignment. See, because it already exists, that is why it failed. Okay, now I will go to the overview of my storage account. Okay, so I hope this part is clear. Now, in order to use this storage integration, there is one another object I have to create, which is called external stage. In order to create it, there is a query which I run in Snowflake. Create or replace stage, in which database and schema I want to create it, and my stage name. The input parameters will be the URL, which is nothing but the URL from your blob storage, then the storage integration, then the file format. You will notice that even though there are multiple folders, I have not mentioned multiple URLs here. The reason is I have given the path for the parent folder Croma. So whatever subfolders or subdirectories are created inside this, it will be by default able to access it. Okay. So you can see that create or replace stage, URL is mentioned, storage integration is mentioned. I have also mentioned the file format which we created before. Okay. So if I run this, you can see stage is successfully created. Now let's say I want to list this stage. Okay. So let's see it is giving something or not. Okay. So you can see it is giving me 6 folders with 6 files. Okay. It is giving all these folders and files. If I list any particular one subfolder inside, then it will give me just that particular file. Okay. Now, similar to list stage, I can also describe. What describe will do is what all parameters I had mentioned that will be provided here. Okay. Now, in order to make sure that these files are automatically consumed inside a Snowflake, I need to create an object which is called notification integration. Okay. And this requires some additional objects to be created in Azure portal as well. One of those first objects is called a queue. A queue is a Azure component which basically stores the message which is triggered by an event whenever we place a new file. Okay, so you can see if I refresh it, it is still there. That means as of now it is not yet consumed by the Snowpipe. So this is one queue which is created. If I quickly show you this, it's nothing. It's just consume some message. There is nothing inside it. Okay, you just specify a queue name, similar to if you add a queue here. Let's say I enter a queue named demo. I just click on OK. It will just create a queue here. Until and unless I link this queue to something in Snowflake by mentioning its URL, it will be of no use. Then you need to click on events. Okay, and you need to create an event grid. Okay, so once you click on event subscription, here you need to mention the name. Here you need to select event grid schema. You can see storage account source is this. Here you need to select blob created. You can also select blob deleted. That is fine. Then your endpoint type will be storage queue. Okay. Then you need to configure endpoint. Configure endpoint basically means it will ask for all the parameters. So let's say here in case I am selecting demo, I will click on select. I will click on create. Managed identity you can leave as it is. Then you click on create. It will just create an additional event subscription. The old one was already existing. I just showed it to you. Okay. Similarly, for this as well, the moment you create a notification integration and the moment you describe it after creation, you will again get one consent URL. You have to paste this URL in the browser and give the accept consent. Similarly, you will get one more permission name. This Snowflake pack int is the constant value. Rest all parameters are variable. Snowflake pack int will be constant. So you need to copy this. The way we gave blob data contributor previously, this time we will give storage queue data contributor. Okay. So I will search for queue here. You see storage queue data contributor. Click on next. Select members. If it's already there, it will show that it has been granted. I'll select this. I will click on select, review plus assign. So you see, it is adding that role, but it will fail because that is already provided. Okay. Now let's move on to the next part. Now we are coming to the part where we will create the tables inside the schemas. So how come without creating service principal, you are able to link Azure and Snowflake? So Salil, to answer your question, service principal, whenever you will be working with a client in case of business critical edition, in that case, you need to create a service principal. Here, I will show you service principal will not be required. The multi-tenant app name permission, which I mentioned, that will work directly. Service principal, why it is required is because there is a concept of service user in the projects to avoid the usage of human user, right? Because I cannot connect my data factory, or I should not connect my data factory through a human user email. That's why the concept of service principal comes into picture. So that is a different concept. It will only be useful when you're working on the live projects with within the company. For individual purpose, you can also create it without the service principal as well. And Ashish, to answer your question, course prerequisites is basic SQL uh, and a bit of Azure. But even if you do not know Azure, that should be fine. SQL will be a must prerequisite to have. Okay, uh, let's start. So I'm using the staging schema. Okay, these are the tables. Stage product. First, I will create the product table. Then I have the employee table. So I will be creating them together. Employee, customer, store, sales, and inventory. As the name suggests, these are self-explanatory. Inventory means how many items are left which are not yet sold. Customer means the customer details, what all details are available for a customer to us. State sales, what all sales were done, for which product that sale happened, which employee made that sale, which customer through that sale came from. Then store, again store name, address, which city, which region, those all things, right? Employee, again the Croma employees, product. So corresponding to each product, there are various products, right? In general market terms, if I speak, each product has various or you can say a definite product ID. There are different SKUs for each product, right? So okay, now as of now, if I see, there is no data, right? Since I have created or replaced all the tables. Now, what we will do is we will see it both ways. One way is I can run a manual copy into and I can do the copy, or Snowpipe will automatically do it. So let's go to our storage browser. Okay. I will go to the blob container. I will go here. I will upload all the files. Even if files are there, I will still go ahead and upload it. Okay. So this I am into customer. So I will browse for the file. I will see that, okay, what is the customer file? Now you can see it is there. So you need to select overwrite if files exist. I will click on upload. It will take few seconds. File is uploaded. I will go to employee. I will click on upload. I'll go to inventory. I will click on browse files. I will click on inventory. Override if files exist. Upload. Then product. Upload. I will browse for file. I will upload the file. It has uploaded. Now let's go to sales. I will go to upload. So in this case, since I have created this, I have all the accesses and everything. But when you will be doing it on individual basis, you need to make sure when you are working in a project, you might or might not have the access for file upload, but for sure you will not be having the access for file delete. Okay. So when you are uploading the file, make sure if there is a policy on that particular blob that in 24 hours only one version can be uploaded, or version of same file cannot be uploaded, it has to be different files, you will land into trouble. So you need to make sure while uploading that you are uploading it with full attention and full focus, otherwise it might cause a problem with the live loads. Now let's see if I go to snowpipe queue. As of now there are no items found. Okay, so let me first show you before running this the pipes. Okay, so the snow pipe or the pipe object which I was mentioning, it basically uses the notification integration which was created. Okay. And then we mention or specify the copy action. So the same way I was specifying to you, right, that you can run this manually, but since we need not rely, because in a live project, I cannot keep on doing this manually. So that's why a pipe is created, which triggers by notification integration. And it has this copy information, or you can say copy into statement embedded inside it. What it is, copy into my target table from source is my external stage, and then the file format. Auto ingest is true means it should automatically take it. Okay. If you have to see the status of a snow pipe, you need to run this command system $pipe underscore status. So let's say if I want to check the status of this, it says does not exist or not authorized. Okay. So just a second. It is an STG. So you see here my context is wrong. So I need to check it. Okay. It says it is there. Okay. It stopped because a stage dropped. You remember we had dropped the stage. So let me do one thing quickly. Okay. I will quickly create this all pipes again, just for the explanation part. Okay. Now let's do it for inventory. Okay, perfect. Now let's check whether my stage table has data or not. So Croma.stg.stg product. So as of now, it is not having data. Then I need to again check the status of my pipe. It says it is running. Okay. Previously, you see, it was stopped due to a stage dropped. Now it says running. Okay. Has the event triggered? Let's go here. Let's check here. Does my queue have any messages or not? No, queue does not have any messages as of now. Okay. So in such cases, whenever you are seeing that, okay, my file is not being picked up, there are two things which you can do. Either you can re-upload your file, okay, that will get the queue to trigger, or you can refresh your uh, pipe. Okay, so let's see. We will try with both ways. Just a second. Let's see if it still does this not have. Okay, no. So this was for product. So let me go to product folder, which is here. My file still exists. I will go again. I will place it one more time. Okay. Describe pipe, and it is this. Okay. Stage. This is fine. See, now my data has come. So either you can upload the file again, or you can refresh the pipe. I have not done anything else except uploading. It automatically loaded the data set. Similarly, for others also, let's try. So let's say I want to access STG inventory. So I will go quickly. I will not here. I'm already into chroma.stg. So my context is already set. I will quickly run this. So as of now, data is not there. So again, the same thing. I will quickly go, and meanwhile, let me show you the queue also here. Queue is blank. So I will go here. This was my inventory. I will go to my inventory. I will upload the file. Since in live system, these files will be coming automatically and on a specific duration basis. So this issue will not happen in case of live system, since files will be coming more frequently. Okay, let it complete. Just a second. So where is the pipe for inventory? Let's quickly select its status also. So select dollar pipe status. Just a second. Yeah. So I will put it here. Let's run this. It's running. Okay. I think this should also come now. Perfect. Okay. Now we saw one way. Okay. Now we will see other way. So let's see for sales. So what I will do is, where I had created the pipe for sales, let's go there. And what we will do is alter pipe, and then the name, which is nothing but p sales. And then I will do a command refresh. This refresh you can write in lowercase, uppercase, it's totally fine. This will refresh it. Okay. Now you see the status is sent. I just showed you both ways, so that should be aware of both. Now, if I want to see my state sales data, right? So select star from. So see, I did not even upload the file again. Same way, I will just quickly refresh all others as well. The reason being, because since stage tables were dropped, so that's why they gave error. Similarly, it will show for other tables as well. Okay. So in case of STG sales, I will write customer. Let's see. I hope customer does have file. So just a second. We go here. Uh, Sorry, I'm in Chrome only. Customer. Okay, file is there. So, and alter pipe customer refresh is already done. So let's see the status of this. Okay, it is running, right? Now let's go here. I was checking for customer inventory sales store. Yeah, so select star from STG customer, and you will have this data. Similarly, let's refresh the other pipes also. So customer we are done with. I think sales is not yet done. So let's refresh the pipe of sales also. And in some time it should be able to do the file load. Similarly, let's do it for inventory also. Okay. So now once this is done, meanwhile in the backend files will keep on loading. Next layer which comes is INT layer, or the integration or transformation layer. In this layer, there are various things which can be done. First is in raw layer, you might have source side data types, right? Source native data types. You will be converting those data types to uh, transformation layer, or the data types, or the data types which can be recognized or which can be easily worked upon by the developers. Okay. So here you will be having respective dimension tables and fact tables. So this is a dimensional model in which there are various dimension tables which mention the values or describe the attributes, right? And then there are fact tables. Those fact tables are related to the aggregated attributes, right? Like inventory, sales. So those all figures are mentioned there. Okay. So these are the dimension tables. These dimension tables have respective primary key constraint as well. Okay. So one of them is dimension product. So if we quickly create this, this is dimension product. Then there is dimension employee. Then these are dimension customer. So I've mentioned not enforced explicitly because so as to mention it, even if you do not mention it, it will still work the same way. But I've just mentioned it to increase the readability of the code. Then comes the fact sales. So fact will be having the aggregated values and the key values from all the dimension tables as for N key. Okay. So you can see all the transactions and everything are there in the fact sales table. Then you have the fact inventory. Okay. Now, what is the process that my dimension tables and fact tables will get loaded? Since we have to implement slowly changing dimension, okay? So in ideal scenario, whatever merge queries you see here, okay? Merge statements using merge functionality in Snowflake, you can do or implement slowly changing dimension. Okay. Here I have mentioned these separately, but when you will be working in a real time project, you will be encapsulating these merge queries in form of stored procedures. You can write those stored procedures as SQL. You can write those stored procedures with language as JavaScript, Python, and these merge statements will be incorporated inside those procedures. Those procedures will be called using tasks. Those tasks will be scheduled for a particular time on which we are expecting that, okay, task will run every 4 hours, every 6 hours, depending upon the business requirement. Okay. Now, what does this merge query says is it will merge into the target, and what it will do is it will select these all fields from the stage table. The join will be on the basis of the key column, primary key, which is product ID, when it will match. So basically, right, if it's existing, then I will update. If it's not existing, then I will insert, right? So it's an upsert, either update or insert. So when my values are matching, or basically that product ID is existing, then I will match. Okay, one of these are my SKUs, or you can say these are my values, or these are the columns which I'm expecting a change in, right? Like is active, a simple column, right? That product might not be available, so that is active flag is N, means it is not available now, or it is out of stock. So those all things. So when matched, then update, set this equals to this, right? And when not matched, then insert, and then same values in the insert one. Now, so you can see number of rows inserted 0, number of rows updated 12,000, right? So this is a, since this is a random data set, so depending upon what values are there, what logic is there, it will accordingly update the target table. So if I see, okay, these all values got updated. Okay, now let's run the merge query for others. I will see in case there is any problem, or by chance the stage table has not loaded. In that case only it will give 0 0 to both. So this means there is some problem with the loading of the employee stage table. Okay, let's complete first the rest one, then we will move on to this one. So dimension customer, let's see. Okay, this also worked. So as of now, employee is the only delta which is not working. Okay, so employee and store. Since this is not working, so first I will check, okay, whether my select query is giving me any data. No, that means STG store is null. Okay, I will go back to my previous query. I will go back to basically the where I had created pipe, right? For just a second. So okay, store also gave 0 0, right? Okay, so let's first start with a stage store. Okay, so stage store, I will see where is the pipe defined for. It is there. Okay, which is P store. Okay, so let's see, is this active or not? Okay, it is running. It says sent as well. So ideally it should have loaded it now. Let's see, is it having any queue pending or not? No. There is no queue message here. Okay. So let me quickly do one thing. Let me go here. There can be any possible scenario why it's not working, but let's upload the store file again just to complete the set. So I will go here. I will click on store CSV. Let's upload it. Okay. And let's try now. Okay, this got consumed. Okay, perfect. So now store is also sorted. I think it was employee as well, which was pending. So let's quickly check employee as well. Then we can run the merge queries. So no. Okay. So let's see the pipe for employee. So it's running. Even though it's running, it did not work. Okay. Okay, it says sent. Let's see a couple of times. Okay, let's go here. Let's go to employee. We'll go here again. I'll browse for file and we'll go here, click on employee and upload it. Okay, let's check now. It should have come by now. Perfect. Okay, so it has come. So now we can run the merge for employee and store as well. So this was the merge for employee. Perfect. Now store. Okay. Now I will come to the fact tables. Similarly, fact tables will also work. Just the only difference will be since it is having the primary keys as foreign keys for all the dimension tables. So they will also be used in the join conditions based upon the requirement. Okay. So I'll be doing a merged. Same case, either update or insert. Okay. Let's do for others. Okay. Now next comes is presentation layer. Okay. So presentation layer is actually your business layer. Okay. So you can also have these column names as custom names. So let's say for product key, I can say uh okay, let's keep product key as product key. I would say for product ID as product underscore identifier, because business might not be knowing, right? Color is fine. So if we create this view and here I will change my context to PRS layer. Let's see. Okay, so this is giving me these are the project IDs, product keys, product IDs, SKU. What is the product name? It's a smartphone. Brand is Croma. Category is mobile. Subcategory, color, size. What is the price? Is active or not? Okay. Now, if I want to fetch a particular KPI, let's say I want to check, there has to be a view for my business team through which they can check what are the daily sales by store or by product. Okay. So we will give them a view. Okay. So when they will run this view, let me set the context to PRS here itself. Select star from. Now I can run this directly. If you have semicolons everywhere, you need not even select anything. But since I might not have semicolons in the top, that's why I'm explicitly selecting. If you have semicolons at end of each query, you just need to double click and it will place your cursor and it will run that query. Okay. So you can see state, city, what was the store, right? What was sold, right? You can group it by particular stores and you can do those analysis. Similarly, if I have to check inventory on hand, or basically means the inventory which is available for a particular store, right? I can create this view and then I will check this. Okay. So you can see these are the products which are available, right? So on hand means I'm having this. On order quantity means 11. Reorder point means till the point if it reaches 15, then or just 15 are left, then I will order it. Customer lifetime value, each customer spent how much amount on Croma. Like if I have to check month over month net sales, this will give, if you add store name and all, you will be able to see that as well, how much percentage change. Then you can add currency to it, INR, USD. What are the top products? You can see those top products, right? So ultra books are this much sold, right? Then store wise performance, so which are the top performing stores which are able to sell uh, highest quantity, or which are reporting good number of sales. So you can see Croma High Street Srinagar is reporting good sales, right? So that way. Now lowest ones, this will show you quite less data, right? See, hardly any sales are there. Latest snapshot you can take, right, in past 30 days. Now you have loaded the data, you have done everything, but this will not work until and unless you have a RBAC setup in the backend. That RBAC is called role based access control in Snowflake, which is the most important part. Okay, depending upon your organization and requirement, there can be various people or roles doing it. Usually account admin does it. I'm doing it just for the sake of showing. Usually it is done by user admin or a person who is having the role of user admin. Okay. Whenever they create a user, let's say you are one user. Let's say if I take an example, I'm if I'm taking an example of Raghu, or if I'm taking an example of Salil. So Salil has a question: does loading the data is overwriting or append? What if there is 1 TB of data table overwrite or append then? Okay. So, Salil, you will not receive such huge volume initially. Okay, this will be an incremental load, as I mentioned, slowly changing dimension. So, whatever is the new data or changing data being changed, that will come. Now, let's say you have a huge volume, right? So, Snowpipe ingests the data in real time. The moment a file is uploaded, that file will be consumed immediately. So, even if your data volume is high, that will not matter. Okay. What is the difference between consumption layer, staging layer, normal layer, and so on? Should there be different schema name, and what is the relation between them? Perfect. Okay. So in medallion architecture, you have silver layer, bronze layer, gold layer, right? So bronze, silver, gold are there, correct? So that way, when you start, so your initial phase or the landing layer, that is the staging layer, that will be your bronze layer. Then your transformation layer will be your silver, and then the last one will be consumption, will be your gold layer. Okay, if you compare it to medallion architecture. Azure tenant IDs there should give access. Schema evolution, Salil, we will cover. There is a separate feature in Snowflake for taking care of evolved schemas that we will see. Favitron and material will not be covered. That is not part of this. Okay. So let's go further. So let's say I'm creating a human user, right? I've created a user. I've given a password. Let's say must change password is true or false. This is the default role, default warehouse. this all. Okay. Same way, once you create this user, okay, always you should set the default secondary roles to all. Why? Because let's say there is a specific default role, but there might be multiple 4 5 different other roles also assigned to user, right? For an example, if you have not set this to all, if until and unless user will explicitly specify the role, he or she will not be able to run it. Or there is a way to do it. You can run a command called use secondary roles all. If you run it, by default, your secondary roles will be enabled. If you want to perform testing with a specific role, then set it to none, because most of all, by default, in all industries, in all projects, your roles will be set to all. You set it to none, then you use a particular role with a command use role, let's say Croma underscore analyst, auditor, developer. Then you can use a particular role. If it's not allotted to me, since I'm running it, as I said, it's allotted to me, so it's showing, otherwise it would have given error. Now show grants to user. So if I want to check, okay, this is the user is granted Croma developer, granted by account admin. Create role if not exist. So these are the roles which are being created. So see, it gave an error. Okay. Why? Because I was not using account admin. I was not having high privilege. I was running it with Croma developer. It does not have access. Right. Now if I run it, it will run it. Same. Now I have created a role, but I have to grant it either to another role or to another user. So I am granting this role Croma developer to user. Now this role has been granted to this user, but what if there are operations happening on the tables in this schema either today or in a particular point in time in future? In order to grant that access, there are various kind of accesses in which are executed as part of RBAC, which are depending upon again the role. So let's say if it's a developer, so even though I have mentioned developer, let me change it to analyst here, and I will change it to INT. So grant select on future tables, whatever tables will be created even in future in chroma.int, those access will be granted to Croma analyst by default. Similarly, I will be executing further ones for developer. Then there are a lot of things. I can alter the data retention time in days for the database. I can set it at a schema. I can set it at table. But the hierarchy which it follows it, if there is a data time retention in days for a table, that will be considered the most high priority. Table data retention time is first priority. If it is not set up, it will take up at a schema. If that is also not set up, then it will take up at database level. Okay. So I think I have covered almost everything. I would like to utilize the remaining time for Q&A. So if you guys can please raise your hands, that will be, then it will be easy for me.
So that is what I had for all of you in this video. I hope you have enjoyed this project and you will be building it end to end really soon. So build it, and if you have any doubt, any query or any sort of thing you want to know from our side, then put it in the comment section and I will be answering really quick. And yes, if you are new to the channel, then make sure to hit the subscribe button and press the notification icon. And if you have gone through with this project video, then make sure to give a like in the big numbers as well. And obviously don't forget to enroll yourself in our extensive basic to advanced Snowflake Mastery Bootcamp. Link has been given in the description.